Welcome back to Code Crack with Raghu. Today we are going to see a Leetcode problem 33, search in rotated sorted array. So the problem statement, here is a problem statement. There is an integer array nums sorted in ascending order with distinct values. So there is an array which is having sorted values. All the values are distinct. Distinct means there is no duplicates. Okay. Prior to being passed to the function, nums is possibly rotated at a unknown pivot index, which means the array may possibly rotated. Maybe it is not rotated also. So such an resulting array, if that array is rotated, how it will be? Like this, they have given the example. Like these are the example, and for example, they have given 0, 1, 2, 3, 4, 5, 6. This is an array. It might be rotated at an at an pivot index 3. So for example, in this they mentioned at pivot index is 3, 0, 1, 2, 3. The 3 index of 3 and the value will be 4. So based on the value 4, it is rotated. So I will explain what is pivot and how it will be rotated, those things. So what we need to think here, one is our all the values are distinct and our array may be rotated, and one more thing is they are given a target and we need to find the target value in the given input. The given array is contains only distinct elements, and it will be sorted and may or may not be rotated. So these are the points we need to think. And one more thing they mentioned, you must write an algorithm with order of log n, order of log n runtime complexity, which is they mentioned the time complexity is order of log n. So for this, how we can write our solution? So what are the solutions are there, and what are the time complexities for each of the approaches? So what is the best one? This is only we are going to discuss here. Okay, now we are going to see array rotation, original array with rotated one. The first rotation, we need to remove the zeroth element and add it at the end. Okay, so you can see after 7 the 0 will be shifted from 0 to last. Okay, second rotation, we are going to shift 1 to last. I am removed here and I am going to add after 0. So third rotation, I am going to remove the element 2 and going the value 2 and going to add it at the end. So you can see, right, remaining all the elements will be same. So now fourth rotation, I am going to remove 3 and add it at the end. So now all the the elements are sorted based on the element 4. Okay, so for, before 4 whatever the elements are there we sorted and added at the end. Now we get two arrays, two sorted arrays. One is 4 to 7, that is one sorted array, and one is 0 to 3, that is also sorted one. So here now the brute force approach, how we are going to solve this thing through brute force approach. We are given with the nums array and target. We need to find the target in the nums array. So first what we need to do now, we need to have one condition. We'll be doing we need to check whether all elements of current element is equal to target. We need to create a loop. Inside the loop we are going to check if nums of I is equal to target. If this is true, right, we need to return that index. That's it. This is our brute force approach for this, right? um, this is under one loop, one for loop. So if you are using one for loop, the time complexity will be order of n. Okay, so we from our problem statement, right, they mentioned we need to solve it through order of log n. So we need to solve in order of log n. So that is our task. So how we can do it? So now we are going to see a binary search approach. So why binary search? Our problem statement is we are given with an array with distinct elements, and the array is sorted and rotated, maybe rotated, or and we need to find a target element in the given array. So for this, why we are going for binary search now? Where we need to use binary search? Binary search needs to be applied where the array is sorted and having only the distinct elements, uh, or the array is rotated with the distinct elements. So here the condition is satisfied, so we are using a binary search here. So this is for binary search, right? What we are going to do in binary search. In binary search, we are having if we are given with a big array, we need to divide that and we need to conquer the output. So divide and conquer is the concept of binary search. Here we are going to divide this array. So for this array division, right, here we need to keep three values. One is left, right, and mid. Left value is the initial index value, so it will be here, which is like 4 is our left value. The index will be 0. Okay, the 0 will be the 0 index will be left, and the end index will be the right. Okay, so from here we need to calculate the mid. So first index plus last index by 2, which means L plus L by 2, that is the mid value. So now I am calculating here mid is equal to L plus or by 2, which is equal to 0 plus 7 by 2, 3.5. The round of value will be 3. So what is the value now? It will be 3. Index of 3 is 7. So the value will be calculated here. Now what we need going to check now, we need to check whether the array is sorted. So nums of left, right, is less than or equal to nums of m. If this condition is satisfied, right, this array is sorted. So from the sorted array, we need to find the target. Okay, need to find the target here. If this is not exist, right, we need to find here. Okay, so from our target it is here only. So here if it is not exist now, then we can find from m to r. Again from the m to r, right, what we need to do now, if this is not found here, we need to increment the left pointer to here. Okay, so m plus 1 equal to l. L is equal to m plus 1. So it will be moved here, and right will be same, and again we need to calculate the midpoint. So from through the midpoint, we need to check whether the values are present. So what we need to do at every iteration, we need to calculate the mid for the left and right, and we need to go through the values. So if the value found, if the target found, if the target lies between this m to r, we need to return the target. Okay, this is our approach. So this is the binary search basic thing. Okay, in where we need to apply, and how you can apply binary search, and how you can find the target. So this is what I explained. If this value is not, if this condition is not satisfied, right, then that is not a sorted one. Like this is not a sorted one, but even though you can apply the binary search there and find out the target. So that is also same. We need to check first from L to M if the values exist or not. If that is not found, then we can go for this M to R. Okay, this is our approach we are going to follow, and I will explain through the given input, right. I will explain the iteration by iteration, and you can get some clear idea, and after that I will write a coding solution. Okay, so now we are done with the binary search. Why binary search we are applying, and for the given input, right, I will explain the logic. Okay, this is now done, and this one is in progress. I will explain how this will be we are going to do. Okay, for the given input, you see a binary search approach for a given input variables. Okay, so for binary search, right, this is our input nums array, and we are going to apply a binary search here. What we are going to do now, first we need to calculate the left. First we need to calculate left. Well, the left will be the initial value of the array, and the right will be the end of an array. So these are done. Now we are going to, we are having, I have written the iterations everything below. So we are going to check what is the iteration and how this will be. First, like I am mentioning, first iteration here. Okay, so this is our first iteration, and we are going to have a value left is less than or equal to right. So if this satisfies left, right, what is the value of left? 0. left means we need to, it will indicate only the index. So index of left is 0, index of right is 7. So I'm going to keep here 0 and this will be 7. If this satisfies, right, yeah, 0 and this is 7. If this is satisfied, we need to calculate the mid. What is mid? 0 plus left plus right by 2. So which is equal to 0 plus 7, which is equal to 7 by 2, which is equal to 3.5. 3.5, which is equal to, round off will be 3. Okay, and the mid value is 3. Now we need to add a mid here because the index 3 will be 7. So I'm adding the mid here. So we calculated the mid, and we have one calculation like nums of mid. So if the target is equal to nums of mid, target is 0, and our nums of mid is, which is equal to 7. So if both are equals, we can directly return the mid index. But currently this condition is not satisfied because our target is 0, which is equal to what is the mid index, which will be the value will be 7. So 0 is not equal to 7. So this is not satisfied. So one, this is not satisfied, and we are going to check a below conditions. So what are the below conditions? We have nums of left is less than or equal to nums of, is less than or equal to nums of m. So if this satisfies, right, what is the if this satisfies, now what is the thing now? Our thing left array, right, that is sorted one. So if that is sorted, and we are going to find the whether our target is present in that. So that is the remaining logic here, right? These are the logics, like target is less than or equal to left, and target is less than or equal to m. Between L to m we need to find. So here we are going to check whether our logic, this condition is satisfied or not. Nums of L. What is nums of L? Nums of L will be 4, and nums of L will be 4, and our target is 0. So this is our target. I will mention both the conditions. Target nums of L is 4, and nums of M. What is nums of M? We calculated the mid, right? What is nums of M? 7. So I'm taking 7. This condition is satisfied or not? 0 is greater than 4? No. This condition won't satisfy. So we need to go to the else loop. So this from L to M, right, our value is not there. From this L to M, our value is not there. So we need to check in M to R. So for this, if we are going to see in M to R, right, we need to move our left index to here. So left is equal to M plus 1. So that is the logic here we have done. Left is equal to M plus 1. So if what is the value of M? The value of M, which is, what is the value of M? The mid index. The index is equal to 3. 3 plus 1 is equal to 3 plus 1 equal to 4. So this is done. So what is our new left? New left will be 4. So now we need to remove our values. On first iteration is done, and we calculated our new left also. So I removed a left here, and I am going to add a left at here, new portion, which is 4. Okay, the left is calculated, and I am going to reset these things like these values for second iteration. So for better understanding, okay, I am removing this one, these values, and this value. Okay, the target is same only, we don't need to remove. Okay, we remove, and I remove this one, and I remove this one. The target is same, right? We no need to remove, and we are going to remove this things. So okay, so this is now done. Now we need to see now new next iteration, m, L and R, mid L R, which is the new positions. So now you need to check if the left of if the left is less than or equal to right. So what is our left value? Left value will be 4, and right will be 7. So 4 is always lesser than, so the condition is satisfied. We are going inside. So 4 plus 7 by 2, which is equal to 11 by 2. 11 by 2 is equal to 5.5, which is equal to 5. So our new mid value is 5. Okay, so we can remove this from here, and we can add it here because our new mid value is now 5. Okay, new mid value is 5. Now I am going to check the condition. If the target is equal to target is 0, and a new mid value, new nums of will be 1, so which is not satisfied. So we are going inside. Nums of L will be 0 now. Nums of M is now 1. So this condition satisfied. So we are going inside. Target is less than or equal to nums of L. What is nums of L now? Nums of L is 0. So this condition is satisfied. We are going to check a next condition. Target is less than or equal to nums of M. What is the new nums of M? Nums of M will be 1. So this condition is also satisfied. So we are going inside of this. So what we are going to do? Right is equal to M minus 1. So now we need to do M minus 1. What is the value of M? 5. 5 minus 1, which is equal to 4. 5 minus 1 is equal to 4. So 4. So if the value is 4, right, already we have L and M. Already we have L in 4. Now our value right is also moved to 4 because we calculated here right is equal to 4. So now right is also we need to move to 4. So right is also now moved to 4. So now right is also moved to 4. Our m is alone here. 2 iterations we completed. Now this is a third iteration. Okay, this is a third iteration. Third iteration already L and M are in fourth position. Okay, left this value we need to see, right? I will remove this one because for confusion. I will remove. Okay, I will remove these things. Remove this. Okay. So now what is the value of left will be 4 and the value of right is also 4 less than or equal to 4. So this condition will satisfy because value of 4 less than or equal to it will be equals. So its condition satisfied. And here mid is equal to left plus right by 2. Left is 4, right is also 4. 4 plus 4 by 2 which is equal to 4. So our new mid value is also now 4. Okay, this is our old mid value. I will remove. Okay, now all are in 4. Okay, now we need to see if the target is equal to nums of mid. Target is 0 equal to nums of mid. Nums of mid will be nums of 4. Nums of 4 is equal to 0. So condition satisfied. So it will return the mid, which is the value of mid. Mid is 4. So 4 is our output. We got the output. So we got the output in 3 iteration and we done it through uh, binary search. So which will be order of log n. So through this is our time complexity. In this order of log n, we completed our task. So we have done whatever the problem statement we have given, right? The same we have achieved. So now we have done that binary search logic for given input and rerun and time and space complexity also we have done. Now we need to see the edge cases to handle. First one is empty array. We handled array not rotated. That is also we handled single element. We handled target not found. That is return -1. That is also we handled and pivot at the start and the end. This is also we handled. Now we are going to see a JavaScript code. Okay. Next, JavaScript code part, optimal code. So for this, right? Uh, now I have written. I have taken the array and the target. Okay, and I write a function where I am passing the nums and target, array and target. Now this function needs to return the index of the value, index of the targeted value in the array. Okay, that only this function needs to return. So if the value is not, if that is not present, value is not found, we have one test case, right? Like target not found. If that is not found, we are going to return -1. So I just return. Okay, if the value is found, that value will return, else no, this lost return will execute. Okay, okay, fine. Now we are going to implement this one through binary search logic. So for this, for binary search, what we need to keep, we need to keep left. Left is the initial most value in an array index. Okay, then the next value is right. What is the right? The length of the array -1. So this is also done. So we have done with the left and right. Okay, then after this what we need to do, we need to calculate a mid value. Before the mid value, we need to check the binary search condition. If this satisfies only, our binary search will work. What it means, the left value will be less than or equal to right. If this satisfies only, our binary search algorithm will apply. Okay, so this is satisfied, which means it is like a sorted one. Okay, okay, fine. Now we have taken left and right and we are going to calculate a mid. So let mid is equal to left plus right by 2. Already we discussed the formula. So I am just mentioning here left plus uh, here left plus right by 2. So this is done. So I am done. I calculated the mid. Now what I need to calculate, if the mid, we need to check whether the mid value is our target. So if the mid value is target, we can directly return, right? So I am checking that one. If the target equal to nums of mid, if this satisfies, what we need to return, we need to return the mid, which is the mid is the index of the mid value. So we are returning. Else, if the mid is not the value, we need to check whether it is a sorted one. If that is a sorted one, the value we are going to check in left and then with right. It is calculated. Now what we need to check? We need to check whether the value whether the left part of the array is sorted or not. If that is sorted, we need to find the target in the left first and then in the right array. If that is not there, then we need to find the right first and then left. Okay, so I'm going to check whether the left part of the array is sorted or not. So I'm just checking the nums of left is greater than, is less than or equal to nums of mid. Okay, if this is satisfied, then the left part of the array from L to M, which is sorted. So for this we need to write a separate logic. Else now, if if else now we need to write a, we need to if that is sorted, right, we need to conquer that, we need to find that target in the left part of the array first and then right. So for that, what we need to write, we need to have one if else here, and we need to check whether the target lies between the left to mid. So I'm just keeping on condition target is greater than or equal to nums of left. Okay, nums of left, and target less than or equal to, no need equal to, we don't need to keep because already we checked the mid value here with the target, so equals we no need. So if this is satisfied, which means from here to here, if this is satisfied, what you need to do, we need to again do a binary search from this array. So for this array already left is here, so we need to shift the right to here. So how it will be, this is going to be a mid minus 1 equal to right. So that is the logic we need to going to write here. Right is equal to mid minus 1. Else what you need to do, left is equal to left. Else now we need to compare from, we need to find the value from this array. So we need to shift the left to mid plus 1. Okay, left is equal to mid plus 1. So this is done. Now if the array is not sorted, then we need to compare then we need to find the value from the righter part and then lefter part. If we find the value from the righter part, what we need to do, if the target is greater than nums of mid and target less than or equal to nums of, which is right. So from this part we are going to check if this is satisfied. What you need to do, we need to move the left pointer to the next of the mid, so which will be mid plus 1. Okay, else we need to check the left part of the array. So for the left part, what we need to move, right pointer to the mid minus 1. So we are almost done the logic. Okay, now we already write a console for this one also. Now we need to check whether our logic is working fine or not. Okay, okay, fine. So now our logic is returned as 4. What is 4? The index of 0. The index of 0 is 4. So we got our answer. Now we need to check this code in the Leetcode. Okay, how this is working. So I pasted the value, I copied the value and pasted here, and I'm running the value. Okay, our test cases are accepted, first, second. So single test case is also accepted, and this is our already we tested scenario, and this test cases are accepted. 3 test cases are accepted. Now we need to submit the value and check, submit the code and check. Okay, now we submitted and all the 196 test cases are passed. Okay, okay, we done with the solution, and that is an optimal one, and that is running on the time complexity of order of log n. Um, okay, guys, you can like, comment, and subscribe our channel for more Leetcode videos, and you can comment what is my next topic. Okay, thank you guys.